Greetings and welcome, friends. Page 52 from Geometry. Big ideas. Here's a handful of problems, four actually, maybe five. No, I did have five. A proper handful, not a baker's handful, just a proper handful of problems for us. Problem 5, it says name a pair of non-adjacent complementary angles. Now, complementary angles, what has to be true about them? Well, their measures add up to 90 degrees. Right? And non-adjacent tells us that they cannot be touching. They may share a common vertex, but will not be allowed to share a common side. So, complementary adds up to 90. Let's see. 41. Does 41 add up with any one of these? 41 and 49, I'm thinking, looks pretty good. I started, by the way, looking at this sketch and that sketch because that was the easiest place to find non-adjacent angles, although theoretically, like this angle and this angle, if they added up to 90, would also have worked, like so. Yeah, so I think that's it. I think it's, let's see, actually, let's name these angles. So I could name that angle EGF. And angle the 49 NJP are complementary angles. And because they are complementary, bonus part of the question, therefore the measure of angle EGF plus the measure of angle NJP is equal to 90 degrees. And vice versa as well. Because we knew this was true, therefore, we knew that these were complementary angles, and then visually we had to confirm that they were non-adjacent. Very good. Actually, are there any just plain adjacent, regular adjacent complementary angles here? Oh, 56 and 34. Yeah, which I could have concluded without even adding those numbers, which is what I did, by the way. I saw that these were adding to 90, that this was a straight angle, and therefore these two had to add to 90 as well. It was the only way. It was the only way. So let's take a look at this. Find the measure of each angle. Ooh, excellent. So these angles, what do you think these two angles add up to? 180, because they are a straight angle when they're together. Is it appropriate to call these a linear pair? Yes, when they are adjacent and supplementary, it's a linear pair postulate where the sum of the angles of a linear pair add up to 180 degrees. So let's do this. Here we go. So what do? If these are a linear pair, therefore they are supplementary. So I'm going to say 3x plus 5 plus tanks minus 7 is equal to 108. And let's combine some like terms here. 3x. Did I make a mistake? Question, comment?
But, how do you automatically?
Because this QRS, I could assume that R was on QS as a result of where it was placed, and therefore this angle and this angle form a straight angle. They had a common vertex, and two of their sides were opposite rays. They were pointing in opposite directions. And therefore, together they had to add up to be a straight angle or 180 degrees. So since that was true, then I said then their measures add up to 180, which is what I started doing. Yeah, good. Let's see. Let's combine some other like terms. Looks like, hey, I thought I done clicked on the purple there. Plus 5 and minus 7. So let's see. 3x plus 10x is 13x minus 2 equals 180. Let's add 2 to both sides. Man, reaching over for my little inkwell here. It's like moving 10 feet across the screen every time. Whew. 182. Oh, guys, I'm scared of this division already. Let's see. X equals. Wait a minute. 13 squared is 169, right? Plus another 13 is 182. So 13 must fit into 182 14 times. And look at that weird X. I don't know, that's fine. So X equals 14. However, they asked for the measure of each angle, not the value of X. Crazy. So we've got to now plug that in. I'll even swap colors for this. Plug 14 in for x in either both of those or one of them and evaluate what those are. So the measure of angle TRQ will equal 3 times 14 plus 5, right? 3 times 14, 3 times 10 is 30, plus 3 times 4 is 12. 30 and 12 is 42, plus 5. So that's 47 degrees is the measure of angle TRQ. Now, if I want to find the measure of this angle, I could plug 14 in for x again, or use the fact that I know that these added up to 180, right? So I could just do 180 minus 47 and find out that the measure of angle SRT is equal to 133. Right, so that one's a little bit easier to find. I guess I should justify that partially. I'll write it down here. Basically, I said this was a measure of angle SRT plus 47 degrees equals 180, and then I subtracted 47 from both sides. So 2 ways you could have found your secondary angle. Scrolling on down. Let's see, 17. Are angle 6 and angle 8 vertical angles? Explain your reasoning. So let's see, angle 6 is right here. Angle 8 is right here. And those are vertical angles because, so I'm just going to verbalize this one, because they share a vertex and their sides form 2 pairs of opposite rays. Check that out, opposite rays. So here, this side of angle 6 and this side of angle 8 is a pair of opposite rays. And then this side of angle 6 and this side of angle 8 is another pair of opposite rays. Wow, I traced that line pretty good, guys. Are you impressed? I'm impressed. I mean, seriously? Let's see. Look at that. Wow, would you look at it though? Like, just barely. There's like a pixel's worth. Wow, that's amazing. I'm impressed with myself right there. Whoa, I just tore the mathematical veil and space is torn and falling apart here. Let's take a look at 48. Make an argument. Yeah, that'll do. Light from a flashlight strikes a mirror, and it's super effective, and is reflected so that the angle of reflection is congruent to the angle of incidence. That is science language, my friends. So the angle of incidence is congruent to the angle of reflection. True story. That's real life right there. Your classmate claims that angle QPR is congruent to angle TPU. Yes. Regardless of the measure of angle RPS. Okay, that angle. Is your classmate correct? Explain your reasoning. Let's see. Now, I guess I'm trying to think of this because I'm coming at it from a geometry background. It looks as though they're referring to RPS as the angle of incidence, huh? I would have thought that it would have been measured to the mirror, but they're measuring it to the perpendicular from the mirror. Has anyone been sciencing recently? Can anyone verify their thing here? I'm guessing that they're correct. So let me erase back. So let's call this angle of incidence, this angle of reflection. We're saying those are congruent. And now your classmate says this angle is congruent to that angle. Let's see, I'll label those. Ooh, how about this dark blue? He's saying this angle is congruent to that angle, regardless of the measure of RPS. Yes, I agree with our classmate. So what we're saying here is, and actually maybe I'll do a full justification of this. Are you guys ready for this? We were told that angle RPS is congruent to angle SPT. That was true because we were told it was true, right? So we'll call this given information. What I'm going to be outlining for us is actually, we'll be working with next chapter as well. It's called a two-column proof, where on one side I make a statement, and on the t'other side I give the reason. Okay, so I give the justification for that. So I'm gonna try to outline this for us. So we know that that is true. I also know that, let's see, I'm gonna say, for sake of time, the measure of angle RPS plus the measure of angle RPQ. What do you think those add up to, guys? What do you think this red and blue angle add up? 90. And my reason for that is going to be def of right angle. I think that's good. Def of right angle. Very good. Yeah, you can sneak out of here if you need to for the sports, and I'm assuming. So let's see. So that statement's true. I can make a similar statement about these two angles. So I'm going to say the measure of angle, or actually, should I do a little bit of work on this first? Let me make this statement first. Measure of angle RPQ is going to equal 90 minus the measure of angle RPS. How do I get this statement from the one above it? What do you think I did? How did I move this to the other side and make it negative? Subtraction property of equality. Right? Good stuff, good stuff. And then I'm going to make a similar claim regarding these two angles. So pretty much symmetric idea. Symmetric, am I right, guys? Look at it's a symmetric drawing. Classic. Measure of angle SPT plus the measure of angle TPU is going to equal 90 because of def of right. And then I can say the measure of angle TPU is equal to 90 minus the measure of SPT, right? I can subtract the measure of SPT from both sides. Now, so far I'm solving this super generically. I don't know what degree any of these are, right? All I know is these two are congruent, these two things are equal, blah, 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 right? That's all I'm doing. So let's see. So the reason that this top one was true was because of def right. The reason this is true was subtraction property. And now watch what I can do. Watch this. I've got another trick up my sleeve. I'm going to say, this is actually linked back to the first statement. Measure of RPS, measure, is equal to the measure of SPT. How could I go from this to this? Now this is going to be a justification that we give throughout geometry, right, the rest of this course. If the angles are congruent, then their measures are equal because of definition of congruent angles. Def of Cong. And yeah, I should say angles there, but that's fine. And now watch this trick. Ready, guys? SPT. Hey, I thought I clicked on the blue here. I did. If the measure of angle SPT is equal to RPS, where's SPT? SPT. Right here. I'll do it this way. Then I can substitute this in for SPT anywhere I like. Okay? Does that make sense? Substitution property. So I'm going to combine this statement and this statement, and I'll have measure of angle TPU equals 90 minus the measure of angle RPS. Guys, this is going to be, this is like the first time you've seen a formal proof. You would have just kind of said in words like, yeah, they've got to be congruent because, you know, these are complementary to each other and these are complementary to each other. Let's see, so this was substitution property. Subs, different than subtract. And now notice this. This guy is the same as this guy. You agree? Those two statements are identical? If the measure of angle TPU is equal to that, and the measure of angle RPQ is equal to that, what do you think I could say about those two things? How do they relate to each other? They're both equal to this green underlined statement. Therefore, how do they relate to each other? Come on, friends. Wow. Come on, man. You're making me feel all alone on the internet here. If they're equal to the same thing, then they must be equal to each other. Almost. If this was the idea, if A equals B and B equals C, then A equals C. This is called the transitive property of equality. You probably haven't heard that one for a while. The transitive property. And lastly, if the measures are equal, then the angles are congruent. So I can just say angle, and notice that I'm transitioning between equality and congruence here. So angle TPU is congruent to angle RPQ. And that's def of Cong again. I'm using def of Cong forwards and backwards in this. So that's like a super formal explanation. The verbal explanation is these two are equal because they are complementary to two angles that are congruent. Something to that effect. But wow, that was a long one, friends. I know. Thanks for bearing with me. Thanks for watching this video to the end. Bye-bye.